Let's use a very simple linear model with one weight W. The prediction is W times X. We'll train this model using a single training data point, X equals 1, Y true equals 3. So the model becomes prediction equals W times 1, which is W. We use mean squared error loss. The loss function is the prediction minus Y true squared. Substitute prediction equals W and Y true equals 3. The loss is W minus 3 squared. This is our loss function, a parabola that reaches the minimum at W equals 3. We want to adjust the weight W so that the model's output is as close as possible to the true value, which is 3. That is, minimize the loss. To minimize the loss, we compute the gradient, or derivative. The derivative of the loss with respect to W is 2 times W minus 3. This tells us how sensitive the loss is to changes in weight W. The direction, if W is less than 3, the gradient is negative, so increase W. If W is greater than 3, the gradient is positive, so decrease W. The magnitude, the farther from 3, the bigger the gradient, and the bigger the correction. This is what lets the model learn in the right direction. We update the weight using gradient descent. The new weight equals the old weight minus the learning rate times the gradient, where the learning rate is ETA and the gradient is 2 times W minus 3. Let's walk through an example. Starting values W equals 0, learning rate equals 0.1. At step 0, compute gradient -6, update W 0 to 0.6. At step 1, compute gradient -4.8, update W 0.6 to 1.08. With each step, the gradient becomes smaller, the weight moves closer to 3, and the loss reduces gradually. After several steps, W is about 2.74, the gradient is close to 0, and the model output approaches Y true. Gradient descent helps minimize error step by step. The final weight converges to about 3, model output matches the target, prediction is about 3, and the loss approaches 0.